In this tutorial, we're going to use QGIS to map the scale of territorial and environmental changes resulting from the war. By running remote sensing analysis, we will compare areas covered with vegetation before and after the conflict to analyze the level of destruction. We use QGIS as an open-source geographic information system. First of all, we're going to create a folder and save our project. And this is the same folder we're going to put all the data we're going to visualize in the map. In the browser tab, there is the possibility to add a base map. We're going to use the OpenStreetMap one to have a reference point for all the information that we're going to upload during this tutorial. To calculate the vegetation, we're using Sentinel-2 data because of its high-resolution red and near-infrared bands are essential for accurately assessing vegetation health and change over time. You can download Sentinel data from different websites, but here we're using Copernicus browser. So once you create an account, you are going to be able to navigate in the platform. And as you can see, first things they're going to ask you is to log in. You're going to receive a link once you're going to register with all the different steps you need to do. So first of all, we select the time range. In this case, I will start by looking at the present condition. So I want to see which images are available from the last month. And then we're going to select the cloud coverage. So the lower the value of cloud coverage, the clearer and more distinct the satellite image would be. Then we will zoom in our area, check the images available, choose the one that reflects our need most, and download the data. It will take a few minutes as different information will be zipped into the same folder. So after downloading and unzipping the files, I will have this folder. Inside we're going to have a granule subfolder where we're going to find the image that we need. So we're interested in using all these different bands raster file. So the easiest way is just drag them inside our QGIS interface. So as you can see now, we're going to have different layers of the same Sentinel-2 satellite image, which consists of multiple spectral bands because each band captures light at different wavelengths and ranging from visible to infrared. So we can cluster them in the same group, just it's going to be easier for our workflow. So we know that all these bands belong to the same satellite image of April 2024. So we want to create a map stack out of this, and to create a multi-band raster of all of these images, the quickest way is to make a virtual layer. So we're going to select raster, miscellaneous, build virtual raster, and then we want to select all the different bands we downloaded, highest, and keep the separate band. It's important also to save the file into the folder, otherwise it's going to be saved as a temporary layer and we're going to lose it as soon as we're going to close the project. So here is our multi-color band raster image. So once we double click on it, we have access to Symbology and we can assign to the different channels, red, green and blue, different bands. And for instance, if we try with the combination 4-3-2 and we applied it, we can visualize the visible part of the spectrum, so having a comprehensive real color satellite image. For the sake of the exercise, we are going to repeat the same process with a different satellite image. For instance, we can select the same month, April in 2023, download another image from Copernicus browser, upload it to QGIS, and repeat the process to stack the information into a single multi-raster band image. Now we have two real color satellite images, one from 2023 and one from 2024. And we can already navigate the interface, the difference in the vegetation. But what we want to do right now is calculate the vegetation index, so more specifically the NDVI, which stands for Normalized Different Vegetation Index, and quantify the amount of green in the landscape. So here are the two formulas. So the NDVI, as we mentioned before, is calculated from the near-infrared band and the red band. So the near-infrared band in our multi-band raster is the band number 8, and the red band in our multi-band raster is the band number 4. So this is the formula that we're gonna put in the raster calculator. So open the raster calculator, and we are gonna first of all save this layer, otherwise it's gonna be a temporary one, as we said before, so it's always important to save it as a geotiff. We're gonna select now the band 8, and we're basically gonna copy the same equation that I showed you before. So it's gonna be band 8 minus band 4, all of these divided band 8 plus band 4, and then we're gonna run the calculation. So the first result is this black and white image, but to run the calculation easily we want to crop the area, so we can use the Gaza border shapefile to crop the NDVI raster. So we can select to raster, extraction, then clip raster by mask layer. Let's take up all the options as you can see in the video, and the result is going to be the same NDVI image, but this time cropped on our area of interest. Now what we want to do is stylize this layer in order to see the different features in the landscape. So let's double click on the image, again go in Symbology and select Symbol Band Pseudo Color. So if we go in the arrows and select color map type, we can select and find the color scale for NDVI, which we're gonna now use to visualize in a more clear way the different features in the environment. So if we go again in the Symbology panel, we are able to change the type of interpolation to see which are the positive NDVI values, so usually ranging from 0 to +1, that indicate the presence of vegetation, and those negative values ranging from -1 to 0, which indicate that there is little or no live vegetation present. Now we're going to repeat the same process as we did before with the satellite imagery of April 2024. So we're going to do the raster calculation again, and we're going to apply the same symbology we apply for the one of 2023 in order to be able to compare the two different indexes. So if we start investigating the different colors assigned to the different values inside the NDVI, it's important to say that we decide to consider only the numbers greater than 0.2 as indicative of vegetation, mostly because it's a common approach to increase the accuracy and reliability of vegetation analysis, to minimize the noise and to distinguish also between different vegetative states. So what we are going to do right now is again open raster and then use the raster calculator as we did before to cluster the values that are greater than 0.2 in our in both of the two NDVI images. So the first result is going to be again a black and white images going from value from 0 to 1, and we can assign a palette unique values to these two different numbers, like transparent to 0 and giving a green color to 1, and this is the result, a raster map that provides a spatial representation of vegetation cover. So what we're going to do right now is repeat again the same raster calculation for the image of 2024 in order to be able to compare and understand the loss of vegetation and so the level of destruction. So again, let's open the raster calculator, and to do a comparison we're going to simply do a difference between the value of 2023 minus the index of 2024. The result again is going to be a raster image, black and white, with values going from -1 to 1. But what we know is that the difference and the destruction are only positive values. Again, with the raster calculator, we're going to select only values greater to 0, obtaining a map with values from 0 to 1, black and white, and again, palette unique values, 0 transparent, 1 we can assign red, and this is the difference between the NDVI of 2023 and the NDVI of 2024, which highlights the level of destruction between these two different time frames. In the second part of the exercise, I want to highlight the possibility of using other Sentinel-2 data resources to calculate the NDVI, not just based on an image from a specific date and time, but using a mosaic. This mosaic combines multiple images into a single image by calculating the median value for each pixel across a stack of images. This is a great option when we want to avoid the presence of clouds or when we need to cover a larger area that cannot be captured into a single satellite frame. So let's move to Google Earth Engine. This part of the exercise will require a bit of coding, but everything is included in the folder, the script and the different steps. So first of all, let's go to Google Earth Engine code editor. This is the main interface. There is a part for the script, there is a part where you can save the different files and projects, and navigation interface. So first of all, you need to register. This is the link where you can register, and it's free for non-commercial and research use. So you need to fill a form and wait to receive a confirmation email. So you can copy and paste the script that I provide in the doc, and also in the doc you can see that I have commented what these different functions do in the script. So what we're doing basically here is just gather the same Sentinel-2 images, but it's easier to filter date, and then again what it's important for us is the possibility of create this mosaic of different Sentinel-2 image, which as you can see is made of different elements, and most of all allow us to have a much clearer stack of information where we don't have interference from clouds, and we can cover a bigger area thanks to the possibility of draw the geometry. So once we did this coding part, we can upload the resulting image on QGIS and repeat the exact same process we did before to calculate the NDVI and the difference. So all the information included in this tutorial are available in this Google Drive folder: the raster files with satellite imagery, the Gaza border shape file, and also the doc with the code snippets. So all the functions of Google Earth Engine are commented, and NDVI formulas as well, and also another doc with the useful links to log in the different platforms.